Okay, I'm going to show you now how to graph a factored polynomial. I'm going to start out with the simplest non-trivial example, so that's going to be a quadratic, and then I'm going to show you how to apply the same process to graph a much higher order polynomial. The first example here is a factored quadratic where our function is equal to 2x plus 1 times x minus 3. Now, if you were to expand this out, you'd end up with 2x squared plus x minus 6x minus 3. And then you could put those x's together, so you'd have a more traditional looking polynomial, but this is in factored form. And I'm showing you how to take it from when it is factored to graphing it. Now, the first thing we're going to do is we're going to identify the degree. Now, to find the degree of a polynomial is the largest exponent. So if this was expanded out, I'd have a term with x squared, plus I'd have a term with x, plus I'd have just a constant term. My highest exponent is a 2, so the degree of this is a 2. A trick to finding it without expanding the whole thing out is if in each of those brackets you've got the highest order x at the beginning, multiply the beginnings together. That would give me 2x times x would give me 2x squared. So my first term, grabbing from the very beginning, my first term is going to be 2x squared. So my degree is 2. And my leading coefficient is also going to be 2. My leading coefficient is 2 because I've got that positive 2 there. And my degree is 2 because the exponent is 2. And I got this by multiplying the first term from each of the brackets after carefully making sure the highest order x term is at the beginning of each of those brackets. Then I'm going to look at my end behavior. Now, this is a second order polynomial, and my leading coefficient is positive, which means it's going to look like this. Because it's a 2, there's no wrinkles in there. If that was another even number, if my order was, for example, 4, then it could be like this. Or if it was 6, it could be like this. However, if the leading coefficient is positive and my order is even, at the very ends, it goes up on both sides. So what is my end behavior? As x approaches infinity, so on my x-axis, as I go this way, y approaches infinity. So on the end, it goes like that. It's going up. Also, as x approaches negative infinity, y approaches infinity. Goes like that. See, I know in general the thing's going to look like this. So at the very end, as x approaches infinity, y goes up. And on this side, as x approaches negative infinity, y also goes up. That's my end behavior. Where are my zeros? So my zeros are my x-intercepts. So that is, where does this thing touch the x-axis? The x-intercepts occur whenever the factored brackets are equal to 0. This is going to be equal to 0 when x is negative 1/2. So negative 1/2 is one of them. And this is going to be 0 when x is 3. So my zeros are at negative 1/2 and 3. You can watch a video on solving quadratics by factoring if this isn't completely obvious to you. Now the zeros are first order. What does that mean? This is a first order 0 because the exponent here is a 1. You don't write it in if it's a 1, but it's a 1. If that was a 2, it would be a second order 0, or a 3, it would be a third order 0. And those affect the way it goes through the axis or bounces off of it. Finally, the last thing I want is the y-intercept. My y-intercept is what I get when x is 0. And if I make x equal to 0, our function at 0, you put a 0 in here, you put a 0 in there, you've got a 1 times minus 3, so f at 0 is negative 3. I'm now going to take all this information and quickly sketch a graph. Because my degree is even and my leading coefficient is positive, I've got this end behavior, so it goes up on both sides. I also have zeros, that is x-intercepts, at negative 1/2 and 3. And my y-intercept is negative 3. So I'm going to go over to negative 1/2, positive 3, and my y-intercept is negative 3. And also I have this end behavior that I approach infinity, y approaches infinity, as x approaches infinity or negative infinity. So I very quickly sketched my polynomial, getting these details in here that I've read off of its factored form. I'm now going to do the same thing with a slightly more complicated factored polynomial. So the first thing I want to do here is find my degree and also my leading coefficient. I'm going to verify that I've got x at the beginning of each of my factored terms, and it's the highest order x in the brackets. I'm going to multiply them all together. So I've got x times x times x times 3x. So my leading term, when I multiply all of those together, the first term of my polynomial, my leading term is going to be 3x to the 4th, which means my degree is 4 and my leading coefficient is 3. My leading coefficient is positive and my degree is even. And you know what that tells me? It tells me that it's going to go like that. If this was negative, it would look like an upside down smile. Because it's positive, it looks like that. And because this is even, it goes up on both sides. If that was odd, it would go up one side and down the other. So my end behavior is as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y also approaches infinity. I'm now going to look at my zeros. X is going to be a 0. Sorry, y is going to be a 0. I'm going to be along the x-axis if any of these factored terms are equal to 0. Sorry, they're not terms, they're factors. If any of these factors are equal to 0. So if x minus 1 is 0, then that means x could be a 1, a negative 3, a negative 1, or here, that's a positive 3. You see, if it was a 3 there, 3 times 3 is 9, minus 9 is 0. There are no exponents here, so these are all first order zeros. Finally, my y-intercept is going to be my function at 0. So if I put a 0 in there, I'm left with negative 1 times 3 times 1 times negative 9. So it's going to be a positive 27. And you can verify that for yourself. Copy the whole thing out, replace each x with a 0, multiply the whole thing together, you should get a positive 27. This is now going to be very easy to sketch. So I've got zeros at 1, -1, 3, and -3. So 1, -1, 3, and -3. I've got a y-intercept at positive 27, so that's way up here. I've got end behavior that goes up at both ends. And because these are all first order zeros, that means we cut right through the x-axis. So it's going to go through there, up there, hit the intercept, down here, up here, and that's what it's going to look like.